Okay, so in this little video, I'm going to show you how to write an algorithm for a problem. I'm not going to do the same one that's in the assignment, obviously, but I'll show you an example of the kind of thing I'm expecting you to do. So let's get a problem to start with. So your problem is this one. Given a list L and a target T as input, return true if T is in L and false if not. Now you're only allowed to use the list processing directives that I've given you. So there is, for example, a built-in function in Python that will do this for you, but you've got to just use things like first and remove first and all of that kind of stuff. And you can test for equality as well. So that's your problem. The first thing that you do when you get a problem like this one, I'll put that there so you can see it. First thing that you do is think about some test cases. These will help you to actually test your algorithm when you've written it. So let's have some test cases. Let's say that L is the list 1, 2, 3, and that T stands for target, is the number 2. Then that should be true because 2 is a member of that list. What about if L is 1, 2, 3 and T is equal to 5? I should output false because 5 isn't in there. We also need to think about what are known as edge cases. Edge cases are ones which are not typical cases. They're ones where you're thinking about what's the smallest input I could get, or what's the biggest input I could get. Well, the smallest input I could get would be the empty list. So in other words here, if L is the empty list and T is the number, well, it doesn't really matter what it is, 42, the output must be false. Okay. We can have any items we like in our list. We could have some strings, so we could have, for example, boo, this list with boo and fish in it. And the target, in this case, could be anything you like, could be a number if you want. Target is 3 and the output should be false. So when you've written some test cases like these, and you've included edge cases such as the empty list, you should be covering both true and false as your output. So here's one where it's true, here's one where it's false. Once you've got these test cases, what will happen is an algorithm will start forming in your mind. And what you should then do is write the algorithm down. So I'll put the problem there, and I'll put the test cases there so that you can see them. And then we'll start writing the algorithm down on the piece of paper, on the big piece of cardboard that I've got here. So I'm going to write it as a flow chart. So this is a flow chart. Hopefully you can see that and it's not off the top of the camera. I'm going to write it as a flow chart. You can choose whether you want to write it as a flow chart or as unambiguous English that can be read by a human being, or you can write it as pseudocode, again, as long as that code can be read by a human being and they can understand what it means. And what you're then going to do is you're going to pass this flowchart to someone else. So in a flowchart, we have a blob that says start in it, and that tells your human where to start. And the first thing we do is we want to read in the input, and we have a parallelogram box for that. So we read in L and T. So in other words, we set up L to have the input value, and we set up T to have the input value. And we'll give our user, our automaton rather, we'll give our automaton some example values. I've thought about this algorithm, and the first thing that I want to do is to ask a question. So I'm going to have a question box here, well, a question, this is a diamond, question diamond. And the question I'm going to have to ask first is actually, is L equal to the empty list? Or you could write here, is L the empty list? Write it in the best way that you can do in order that your person will understand your banter, basically. If your person doesn't understand your banter, then you're going to have to write it in a different way. The reason I'm asking is L the empty list here is I'd actually like to ask, is the first element of L equal to T? But if I ask that, if I call first on L and it's the empty list, you should know by now that that will actually cause an error. So therefore I'm going to test it to see if it's the empty list first. And then I have the answers yes and no, because this is a yes/no question. So if the answer is yes, L is the empty list, well, what do I know? Well, I know that I've got to the empty list and I haven't found T. So I can now return a value, and the value that I should return is false, because I've got to the empty list. T is not in there. Clearly T isn't in there because there's nothing in there at all. So therefore the answer to the question is false. Otherwise, if I'm down here, then I know that L has got some elements in it. So I'll have another question now. So I can ask a second question now, and I can ask, is the first element of L, and I can do that now, is it equal to T? And if the first element of L is equal to T, then I've answered my question. Given a list L and a target T, return true if T is in L. I know that it's in L now. In fact, it's currently the first element. So if the answer to that is yes, I can return true. Excellent. But if the first element of L isn't T, well, what do I want to do? Basically, what I want to do is I want to throw away the first element of L and then go around the loop again. So I now have a rectangular box, which means do something, and I say I'm going to let L equal to remove first of L. So remove first of L, if you remember, that takes a copy of L, removes the first element and then returns it. And this assigns that new value to L. So that line there removes the first element of L. After I've removed the first element of L, what do I need to do? Well, I need to check to see if L is empty again, because having removed the first element, it might be empty now. So I go back to here. And that is probably my whole algorithm, but I'll need to test it now. So let's test it using one of my test cases. I'll take the first test case here. So I'll say, okay, L is equal to 1, 2, 3, and T is equal to 2. So what I would now do is I would pass this entire piece of cardboard across to my human, my test subject, and I would say, please run this algorithm on this input and see what you get. I'll run it for you now. So we read in L and T, so we've done that. We've got those read into our computer, so our computer memory is here. We then say, is L the empty list? L is not the empty list, so I go down here. Sorry, that should be a no there. So I go down here. Is the first element of L equal to T? Well, no, because the first element of L is 1 and T is equal to 2, and they're not equal. So I go to here and it says L is equal to remove first of L. So I now update L to remove the first element completely. So L now has the value 2, 3. And I go back round here. Is L the empty list? Well, no, it's not. So I go down here. Is the first of L equal to T? Well, the first of L is now 2. T is 2. So the answer is yes. And I end up here, return true. So I now say output is true. And that's what the algorithm then returns. So what you should do is try to do a similar job to all of this, but with the palindrome problem, and then pass your algorithm and an input to your algorithm to your partner in crime, your stooge, your automaton, and see if they can do it. If they can't understand your banter in the algorithm, then rephrase it. But they're not allowed to ask you any questions along the way. They can't say, what does this mean? Or how do I do this? If they don't understand what it's doing, if they don't understand what a double equals is, maybe rephrase it. Or maybe they will understand what a double equals is, in which case you're fine. So have a go at that. See if you can write down something like this. As I say, it doesn't have to be a flow chart. It could be unambiguous English, or it could be pseudocode, but your person has to be able to understand it. Hope that helps. Good luck.